All right, let's keep converting Cartesian functions to polar coordinates. So the next one I have here is 3y minus 7x is equal to 10. And I cut and pasted our toolkit here, and let's see what we can do. We want to convert this to a function of r and theta. So let's see, the simplest thing, we have a y and an x. We can just substitute. We know that y is equal to r sine of theta, and x is equal to r cosine of theta. So let's just substitute. So 3 times y. Well, y is the same thing as r sine of theta minus 7 times x. Well, that's 7 times r cosine theta is equal to 10. Remember, these just came from SOHCAHTOA, nothing fancier than that. Let's see if we can simplify this or write it explicitly in terms of theta. Let's see. So we could factor out an r. So you get r times 3 sine theta minus 7 cosine theta, right? We just factored out an r is equal to 10. And now divide both sides by this big expression, and you're left with r is equal to 10, 3 sine of theta, 10 divided by 3 sine of theta minus 7 cosine of theta. And we could also write this, we could say, well, this is r is a function of theta. We could write r of theta. Right? R is a function of theta. I just felt like doing that so you can show that the function notation even works in polar coordinates. Let's do another one. Then we cut and paste our toolkit. Look at that. All right. Next one. So it says y is equal to 2x minus 3. Well, we can do the same thing. We know what y and x are in terms of r and theta. Y is equal to r sine of theta. So let's write that. R sine of theta is equal to 2 times x. Well, x is r cosine of theta. R cosine of theta minus 3. And let's see if we could separate the r's and the theta. So let's subtract this from both sides. So we get r sine of theta minus 2r cosine of theta is equal to minus 3. Just like the last problem, we can factor an r out. So we get r times sine of theta minus 2 cosine of theta is equal to minus 3. Now divide both sides by this expression. So you're left with r is equal to minus 3 divided by sine of theta minus 2 cosine of theta. There you go. All right. Now they want us to do some problems. Let me clear everything. Now I want to do some problems we're going to convert the other way. Let's write our toolkit down. It's proved to be useful. All right, now they want us to convert from polar to Cartesian coordinates. And so they give us the polar function, r is equal to 4 sine of theta. So how do we convert this into a function of x and y? So let's see here. There's no obvious, let's think about it a little bit. So we know we have this equation, y is equal to r sine of theta. So can we write sine of theta? Well, we could just, let me do a little side here. So y is equal to r sine of theta. If we divide both sides by r, what do we get? We get y over r is equal to sine of theta. Right? Well, that seems to be helpful. We have a sine of theta there, and then we have something that at least it gets rid of the theta out of the equation. We're still left with an r, but makes it a lot easier to look at. So let's do that. Sine of theta is equal to y over r. So let's substitute that there. So we get r is equal to 4 times sine of theta, which is y over r. So 4y over r. We could multiply both sides of this equation by r, and you're left with r squared is equal to 4y. And we know what r squared is equal to. That tells us right there. R squared is equal to x squared plus y squared. So you get x squared plus y squared is equal to 4y. And there we have it. We have it at least in an implicit form. We don't have an explicit equation, but I think that's good enough for now. So you see, it's really just a lot of algebra and I guess a little bit of trigonometry, but really a lot of algebra, just kind of figuring out how to use this toolkit. Let's do a couple more. So let's say, let me paste the toolkit. Let's say that we have the polar coordinates r is equal to sine of theta plus cosine of theta. And just so you don't lose the big picture of what we're doing, this is if we could graph this, you could put your graphing calculator onto polar coordinates, and I'll do future videos where we do graph it, and it'll produce some graph. As theta changes, as we go around the circle, the radius will change, and it'll produce something. I don't know what it might look like flower petals or something. I don't know. I don't have the intuition of exactly what this will look like. But what we're saying is when we convert to x and y's, if you actually graphed it in Cartesian coordinates, it would look the exact same way. That's all we're doing. How do you express the same relationship in terms of x and y's? So how do we do this? Well, in the last one, these two we can rewrite. We can divide both sides of these equations by r, and we can this is the same thing as sine of theta is equal to y over r, right? I just divide both sides by r. And this is the same thing as cosine of theta is equal to x over r. Just divided both sides of this equation by r, and you get this. So now we can use this to substitute back here. So r is equal to sine of theta. Well, we know that's equal to y over r. So it's equal to y over r plus cosine of theta. Well, cosine of theta is equal to x over r. X over r. And now we can multiply both sides of this equation by r, and we're left with r squared is equal to y plus x. And we know what r squared is now. That should be second nature, hopefully. So it's x squared plus y squared, right? That's r squared, is equal to y plus x. There you go. Let's do one more. Let's do it without our toolkit, and I'll do it in a different color. So let's say we had r is equal to a squared. So they're leaving it abstract. But a is some constant, so we hopefully know our intuition from a couple of videos ago that this should be a circle, right? If a was 3, then we'd say, oh, r is equal to 9, right? 3 squared, and then it'd just be a circle with a constant radius of 9. So how would you write this as in Cartesian coordinates? Well, we know that x squared plus y squared is equal to r squared. So one thing we could do, maybe just square both sides of this equation. So you get r squared is equal to, what's a squared squared? Well, it's a to the 4th, right? It's a to the 2 times 2, so a to the 4th. And we know what r squared is. It's x squared plus y squared. So you get x squared plus y squared is equal to a to the 4th. Not too bad. Not too bad. And that's really, I mean, that'll get you pretty far in converting between Cartesian and polar coordinates. In the next video, we'll maybe explore a couple of these graphs to hopefully give you a little intuition of really how the relationships between r and theta really works. See you in the next video.